好的，Hello，大家好，欢迎来到原力区直播间，我是本次活动的主持人武荣，欢迎大家继续跟随我们探索 Web 3.0、Web 3先行者系列活动，主要是面向不同的公链，邀约行业资深大咖进行分享和交流。大家知道，在我们之前的活动中，不仅有知名的公链，还有依托于不同链的明星生态项目。希望我们可以共同携手，一起共建共享 Web 3.0生态繁荣。Hello everyone, I'm Dolores. This is our fourth open day of fourth Web3 community. We are a non-profit community, and now we are having a series of Web3 projects featured on our community. There are not only public chains here, but also ecological developers and builders relying on different chains. So we welcome everyone to speak out through our platform and promote the development of Web3 together. Thank you for joining us at the fourth open day, where we are going to talk about everything Web3 and the future of the internet. And I'm so happy to have you here today. So we are also a best place to launch or discover the brand new products you have never discovered before. 那本期的 Web3先行者活动呢，也是我们的222期原力开放日。我们特别邀请到呢KILT Protocol 的核心开发者 Antonino and Dudley 做客原力区直播间，有2位嘉宾为我们分享主题：区域中心化身份标识符和建立 Socialkyc。So, hey everyone, in the 222 events of the fourth open day, Antonino and Dudley, the core developers at KILT Protocol, are invited as guest speakers here to share the topic about decentralized identities and building with social KYC. The KILT Protocol was initially developed by the BOTLabs, a blockchain protocol for ensuring sovereignty and anonymous and decentralized identifiers. KILT Protocol also provide a way to represent your identity without revealing things you prefer to keep private. In 2018, KILT was an early adopter of Substrate and built on the Polkadot as a parachain in the Polkadot ecosystem. In September 2021, the KILT became one of the first projects in the world to win the parachain slot on Kusama, which allowing the KILT service to be available as soon as possible. 那好的，首先为大家就是介绍一下 KILT Protocol 啊。KILT Protocol 是由BOTLabs GmbH 开发的，它是一种用于开发自主、匿名、可撤销和可验证的去中心化标识符的区块链协议。那 KILT 协议呢，提供了一种可以表示我们的身份的这种创新的方式，无需透露任何您希望的保密的这些信息内容。在2018年 ，KILT Protocol 也是建立在波卡链上啊。是 Substrate 的早期使用者，那 KILT 的使命也是将我们个人的数据的控制权交还给所有的所有者，他们恢复了个人隐私，并且掌握到我们所有的这个数字的控制权呢。它于2021年的9月是正式推出的，然后在11月是完成了它的去中心化，就是完全的去中心化。那在2021年就是9月的时候。KILT Protocol 也是成为了全球的首批赢得波卡网络 Kusama 平行链插槽的项目之一。就是这个也是推动了 KILT Protocol 可以更快、更好的继续发展。那好的，话不多说，就有请我们的第一位嘉宾 Antonino 开始精彩的分享。So let's move on the sharing from the Antonino. Hey Antonino, it's our pleasure to have you guys with us here today. I'd like to welcome you here on behalf of our entire Web3 community. So are you ready? I'd love to hear your introduction and say hello to our Chinese audience as well.
Yes. Hello, ni hao everyone, and thanks for inviting us. It's a pleasure to be here. Should I go on and share my screen already?
Okay. Please do your presentation right now. I will stop my speak sharing. Yeah, so you can share your screen right now.
Can you confirm that you can see my screen?
Wait a second. Oh, yeah, we can see it. It's
cool.
perfect.
Okay.
Please go on.
All right. Yes. Thanks. So yeah, hello everyone. Thanks for taking some time to attend this presentation. My name is Antonio, and I'm a blockchain engineer at KILT, and I am with my colleague Dudley, who is also a blockchain engineer, and he will give another presentation after me. Today, my presentation would focus on KILT and how it provides a decentralized identity infrastructure for the Web3. Core to the KILT ecosystem are DIDs, which stand for decentralized identifiers. So what are they? The W3C standard defines them as a new type of identifier that enables verifiable decentralized digital identity. But what does it mean? Simply put, an identifier is verifiable if we can somehow make sure that it refers to the right subject. And this is why we use biometrics on real-world documents, for instance, like a picture of our face or fingerprints. And in contrast, DIDs use different cryptographic techniques to prove this ownership. On the other hand, an identifier that is decentralized allows any entity to generate and manage its own identifiers without relying on any centralized registry or controller. And so basically, in case of decentralized identifiers, I don't need to rely on any third party to generate and manage my identity. And typically, this is the case with how we actually handle email addresses or phone numbers, for instance. And so these verifiable and decentralized identifiers allow us to create self-sovereign and cryptographically secure identities for a variety of use cases. Moving on, so how do decentralized identifiers differ from centralized ones in a typical use case involving Alice? So on the left is a common example of centralized identity management with a typical providers such as Facebook, Google, or Apple. In this case, these players have full control over Alice's information and full access to her information. So they're technically not limited about what to do with this information and who to share it with. Furthermore, having several active identifiers, for instance, email addresses, can be very expensive. And since the process of creating new email addresses usually takes some time, including some kind of verification, like a CAPTCHA verification or something like that. And if you want to manage multiple email addresses, can be a challenge for most people. And last but not least, different providers have each of them have their own copy of Alice data. So in case Alice wants to update some information, she would have to do so on each of the websites that she's registered that has her information. In contrast, the approach on the right sees Alice being in full control over her identity and also the way that she can update information. And so this acts as a single source of truth for all the information, making it possible to update all the identity-related information only once and see the updates reflected in all the services that use this information. Moreover, depending on the type of the DID that is used, it is often inexpensive to create multiple of these identities, which has the great privacy benefit of reducing the possibility that these big players can then track the usage of one specific identity across multiple services, because to them it would look like different identities are used in different services. So it's harder to link activities across multiple services to a single user. So as I said a few minutes ago, while you can think of email addresses or phone numbers as more or less typically centralized identifiers, DIDs can be thought of as email or phone numbers that can be created on the fly by the user and whose ownership can be proved without having to rely on a central party and without having to click on long links. For instance, if you want to verify your email address, or answering phone calls or text messages if you want to prove your phone number. So a DID is just a URI, which stands for a Uniform Resource Identifier, and is composed of three parts that are separated by semicolons. So the first part is always DID and indicates that this URI represents a DID. The second part is the so-called DID method, which must provide a specification somewhere on the internet, and I will provide links at the end of the presentation where to find all this information. The DID method indicates how DIDs in this class of DIDs, so for example, in this case, how KILT DIDs are created, updated, and deleted. And the third part is the DID identifier. So each identifier must be unique within each DID method, and each method must specify what are valid and invalid identifiers and what is the structure of each of these identifiers. Of course, a DID is just a long string and usually doesn't have any specific meaning attached to it. So this is why a DID usually is associated with a DID document, and the retrieval of the DID document starting from a DID, so starting from this very long string, is what we call resolution. And it works very similar to what the DNS system does nowadays, where you can translate from domain names to IP addresses. So the same would be for DIDs. You resolve a long DID string to a DID document, which contains information that is more useful. So a DID document is self-contained and includes public information about the DID subject, and is totally under the control of that subject. So anyone could provide a resolution service, but of course, for the sake of decentralization, a distributed ledger would be a very good choice. It would make sense. The Decentralized Identity Foundation, or DIF, also provides a universal resolver that is able to resolve DIDs belonging to multiple different methods, so including also KILT DIDs. And and the implementers can then extend this universal resolver to add support for their own drivers, the way that KILT did. There is a link on the bottom left where you can actually also access the universal resolver and play around with it. And there's also going to be links at the end of the presentation. So a DID document has multiple sections, and it typically is either a JSON object or a JSON LD document, which is kind of JSON on superpowers on steroids. If JSON LD is used, a DID document must usually provide one or more JSON LD context, which describes the semantic meaning of each of the keys in the DID document. So in this case, there is a standard JSON LD context, which the W3C provides, which is this w3.org/ns/DID/v1. Then each DID document must be uniquely identifiable and thus must have a unique identifier, and the value of this identifier must match the DID that is being resolved. So in this case, you can see that the DID and the DID document ID match, and that means that proves the link between the DID and the DID document. Then the DID document also has a set of verification methods, which is the set of public keys that the DID subject controls. Each key might have a different purpose, and what the purpose of that key is explained in the next slides. But in this example, we can see that the DID document controls 4 keys, 3 of which are ED25519 keys, and 1 is an X25519 key. Each key is also identified by unique ID. In this case, in the case of KILT, it would be the hash of the public key that is hex encoded, and that represents the key ID. And so each key must be unique because they must be uniquely retrievable given a DID document. So there cannot be 2 keys with the same ID. So the authentication section contains the keys that the DID subject can use to authenticate itself to other parties. For instance, when visiting a website, if the website supports users authenticated with a KILT ID, they can use their KILT ID to authenticate to the website and provide some information the information that the website requires. But authentication keys are also used to sign and authorize updates to this DID document. So only the entity that is in control of the authentication key can make changes to this document. And that's typically the DID subject. And these, as well as the next sections in the DID document, can either reference keys that are part of the verification method, like in this case, it referenced the key1 key, or they can also include their own additional keys, which are not part of the verification method. And which way to go is, depends on the implementer of a specific DID method. The key agreement key is the set of keys that other entities can use to encrypt the traffic to the DECENTRALIZED subject. This provides end-to-end encryption so that a party can retrieve this key, use it to somehow compute a secret that only the receiver of the encrypted message is also able to compute, given its private key. And so entities can then use this key to encrypt the traffic or encrypt the message, send it over to the DECENTRALIZED subject, and the DECENTRALIZED subject is the only one that is able to decrypt the message and access the content. The assertion method is the section that contains the keys that are used to express and sign any kind of assertion. An assertion could be a verifiable claim or a verifiable credential. In our case, this is the key that the blockchain needs to authorize writing new credentials on the KILT blockchain. And the capability delegation keys indicate what is the set of keys that a DECENTRALIZED subject can use to delegate some sort of capabilities to other parties. In our case, in the KILT blockchain, these are the keys that the blockchain expects to verify and authorize operations to write new delegation nodes on the KILT blockchain, and having like hierarchical trust structures. In general, the DECENTRALIZED standard simply specifies the semantics of each key type. But yeah, how those keys are then used by DID method implementers and by applications, that is totally application specific. So the DID standard doesn't enforce any kind of usage on these keys. It only provides a standard so that multiple entities, multiple companies, multiple ecosystems can agree on a shared meaning for each of these fields. And then the services set allows the DECENTRALIZED subject to enrich the information that is in the DECENTRALIZED document. For instance, a service endpoint could expose the email address or the website of the DECENTRALIZED subject, or more complex use cases might also include some kind of more advanced end-to-end encrypted messaging systems. For instance, DID-COM that make use of DID keys. There will be also one slide at the end with some useful link to read up more on DIDs and all the related standards. Okay, so now that we have a rough ideas, I hope, of what DIDs are and how they work, let's briefly talk about verifiable credentials, which are both a very good fit to use DIDs and also at the very core of KILT. A verifiable credential, or VC short, is made of a set of claims that an issuer makes about a subject, and that a verifier can use to validate certain properties about the subject. So if you think of a digital passport as a credential, the passport contains claims such as name, surname, date of birth, and so on. And it is issued usually by a country's government, which would be the issuer to the passport holder. So me and everyone else in the world, I guess, which would be the subject and the holder of the passport, and then is verified, for instance, at the airport when boarding on a plane. So the airport authority would then be, in this case, the verifier of the passport. So in the digital world now, we have a problem of making sure that someone using a credential is actually the owner of that credential. One solution that is used, for instance, for most websites is to use bearer credentials, which are considered valid for whoever presents them. So even in the unfortunate case that they have been leaked or stolen. And this is the case of some types of internet hacks, for instance, where hackers can steal social media or online banking or other type of tokens, and they can then impersonate the victim on said websites or services. Another solution then that somehow mitigate this problem is to use some sort of proof of possession, meaning that the presenter of a credential must prove ownership and or anyway authorization for using the credential. So they would have to prove that the credentials were issued to them and that they are the entity authorized to present this credential to a specific service or website. But this means that the identity to which the credential was issued must somehow be verifiable, and which makes, of course, DIDs a suitable solution given their properties. So, of course, it would be possible to use, for instance, email addresses as identifiers, for instance, but then each time, and if you want to implement some kind of proof of possession, then each time the credential is presented, the user would have to verify ownership of the email address by clicking on some link or providing some secret code that is sent via email. Alternatively to email addresses, also simple public keys could be used, but then we should consider how the key is encoded, what key type it is, or what happens if the private key is lost. On the other side, DIDs allow the subject to prove ownership with the keys that we have shown in the previous slides, and also it provides flexibility that is needed to update the keys in case some keys get lost or compromises without changing the identifier, so without changing the user's identity. And also to use key types for more advanced signature schemes, for instance, multi-signatures or zero-knowledge proofs, for instance. So now let's see how KILT implements the IDs and what role they play in the KILT ecosystem. So far, KILT provides two classes of DIDs, light and full DIDs. A light DID is created and resolved entirely offline in a peer-to-peer fashion and does not have any requirement for a blockchain or other resolution service. They are created starting from a KILT substrate address and are identified by leading light DID KILT light namespace. They don't involve any DID document or any blockchain, which on one side makes it easier, faster, and especially cheaper to use. But on the other side, they can't support more complex use cases, which involve, for instance, several keys or key updates over time. So because of their properties, they are mostly suitable for quick or ephemeral interactions, where parties are not required to make their entities publicly available. So an identity would only be valid in the context of a specific interaction between the two parties. On the other side, full DIDs allow the owner to have multiple keys that fulfill different purposes, as we have seen in the previous slides, and also to rotate those keys over time. They do require the KILT blockchain to be resolved and can also be created from any ED2519, SR2519, or ECDSA key pairs. The last one is the one that is also used on the Ethereum blockchain. And these are suitable for publicly recognized entities whose identity must be verifiable, as is the case for most issuers, which want their public information out there so that people, especially verifier, can trust the information of the issuer and they can trust the credentials that such issuers issue over time. So now I'll quickly show, if I can share another screen, the docs and how they are done and how they are, yes. So this is from the documentation that KILT has for developers. So feel free to check it out. There are some links also in some link at the end of the presentation for this. So the way that the SDK, KILT provides an SDK, a TypeScript SDK, and also implements a blockchain node with a blockchain runtime based on Substrate. So the way that the SDK exposes the management of DIDs is by giving a chance to create either light DID or full DIDs, or also to create a light DID and at a second time update it to a full DID without losing all the credentials that the light DID were issued to the DID. So the SDK provides a key store, which must be used to generate these secrets, these key pairs. And then the keys that the key store generates can be used to generate a light DID with either only an authentication key, which is the minimum set of keys that a DID requires, or a light DID can also have an optional encryption key, which is, as I said, is used to encrypt traffic to the DID subject, and also potentially some service endpoints. Like in this case, there is one credential endpoint, which, for instance, KILT collators might use to expose the fact that they are collators and expose their social media endpoints, for instance. Full DIDs have a very similar syntax as light DIDs without the light identifier. So it just DID KILT and then a KILT address. And they allow for more complex use cases where multiple keys can be specified. So in this case, yes, through some of the classes that the SDK exposes, like the full DID creation builder, it's possible to combine multiple keys into one single DID creation operation, and then submit this operation on the blockchain, with the result that a new DID is now created and the keys are only under the control of the DID subject and stored inside the secure key store. Then the SDK also provides features to update the DID and, of course, to delete a DID. And the creation of DID requires the payment of a deposit, which is around 2 KILTs. And this is to make sure that whenever a DID is not used anymore, the DID subject, the DID owner, has to get rid of the DID and then claim this deposit back to keep the overall blockchain state as small as possible, only including information that is actually needed by any party. Another feature that DIDs offer, as yes, maybe you can see here. Oops. Yeah, okay, I'll just share this one here. It's batching multiple operations. So most of the operations within KILT require the DID subject to sign off the operation with the DID. So for instance, creating a credential or creating a C-type or creating a delegation requires a specific DID key. So it's only restricted to full DIDs. And KILT also provides the opportunity to batch multiple operations together. So a DID subject can batch the creation of, I don't know, 10 different attestations or 5 attestations and 5 delegations all in one operation, saving on transaction fees and using the same DID nonce. Yes, so last but not least, there are also some products that are built on KILT. Socialkyc is one of them, which is an identity attestation service that allows users to regain control over the digital identity by issuing different credentials that are mostly proving that a specific owner, a specific KILT user, is the controller of a specific social media profile. For instance, Twitter. For instance, GitHub. You can quickly check that. Yes. Yes. So users can get a credential to certify their Twitter account, their email address, or their Discord account, or their GitHub account, and then use these credentials in places where this information might be useful. Stakeboard is the staking platform for the KILT coins. Sporan is a wallet to store all the DIDs in the credential, and it's this small thingy here with some DIDs and some credentials. And then the DID sign, or DID sign, which allows user to digitally sign any file and in the browser with their DID, and then they can share these digitally signed files with other people and prove that they signed a specific batch of information at a specific time. And then, yes, just a little bit of a heads up. This is, of course, not any financial investment. It's a purely technical discussion, so don't take this presentation as financial advice. There are some resources here, which I guess they will be shared after the presentation concerning both the KILT ecosystem, but also the wider DID and verifiable credential ecosystem. And thanks for listening. So I am not sure now if we do have questions or if we take them later.
And it's okay. The Q&A will be later, so you just quit your. Okay.
Okay, thanks. Then I'll give the stage to my colleague, Dudley.
Thanks, Antonio, for amazing presentation today. This is really awesome, and I do think it's a lot of what you have shared about KILT Protocol parts and DID documents, DID management, as well as around this information. So they are really helpful for us to know about KILT Protocol. 好的。非常感谢 Antonio 的精彩分享，在 Antonio 的分享中呢，就是为我们提供了很好的一个保护数据隐私和安全性的一个解决方案啊。就是我们知道，就是在互联网的现有版本，也就是称为是 Web2， 过度是依赖很多像 Facebook、谷歌等等这些将我们连接到全球网络的中心化的中介的数字标识符。这些导致了我们数据安全相关的问题，比如说身份盗窃，以及有针对性的一些攻击，还有隐私的一些侵犯等等。那除此以外呢，就是当前呢我们的数字身份管理，还有一个关键性的问题，就是用户的很多信息是在很多个平台上共同分享的，这就使得用户就很难发现他们的个人数据已经被盗用，或者是甚至被货币化了。那随着 Web3 的发展中， DID 也可以也是作为一个数字的标识符，就是去中心化的数字标识符啊，它是由区块链技术提供支持，然后中心化的就是去中心化的数字标识符 DID 呢，为我们现在所面临的这些问题提供了一个解决方案。它就是可以使我们的用户在使用数据的过程中拥有更多的控制权，并且能够自主的选择我们所希望共享数据的一种方式还有对象。那 KILT 协议刚才在 Antonio 的这个项目就是展示中，他也给我们就是展示了，它是利用 DID 和区块链技术的这样的一种方式，然后使身份验证的企业服务和机构创建各式各样的 DID， 然后让用户控制他们的数据。那并且呢，这种开源化的区块链协议也是允许用户可以发布可验证、自主和匿名的 Web3凭证的。当然也包括现在我们的 KILT Protocol 推出了比较Antonio 刚才介绍了有就是 Wallet 还有 Socialkyc 等等。他们这是像 Socialkyc 呢，这是一种关于数字身份管理的工具哈。允许用户呢可以存储和管理他们的个人 DID，同时也允许用户可以自主的决定，就是什么平台、什么在线服务可以访问这些私人的信息。那借助 Socialkyc 呢，也是可以随意的访问元宇宙和 Web3，它可以用自主发布的这样的一个数字标识符，然后建立链上的 DID，然后将这些可验证的凭证连接到 DID 上。总体而言呢，就是 DID 它正在向 Web3过渡的这样子的一个改变了我们现在 Web2所存在的游戏规则。那除了完全的去中心化之外呢，DID 也是解决了数据隐私和安全问题，同时也让用户能够更好的控制他们的数据。所以，我们就感谢安东尼奥为我们展示了去中心化的身份标识，和这个 Socialkyc，并且期待 Dudley 能够继续为我们就是分享更多关于 KILT Protocol 的一些内容吧。So absolutely, really appreciate that perspective, and actually, it's a really point for us to know a little bit more about the KILT protocol overall. If we were looking at opportunity in this space of course, absolutely, I know Dudley will be talking a little bit more about the social KYC too. So before we move on this point, you might want to add something. So next, let's welcome Dudley to share us more about the KILT protocol and the social KYC. 好的，那接下来就有请我们的第二位嘉宾 Dudley 为我们分享更多的关于 KILT Protocol 如何为 Web3的去中心化身份认证管理系统提供一个赋能工具。Okay, Dudley, are you ready?
Yeah. Hi there.
Okay, love you to hear your introduction. So firstly, say hello to our Chinese audience online.
Hi there, everyone. Nice to say hello to everyone.
Okay. Please do your presentation, and I will stop my presentation right now. Okay, we can see your screen. It's perfect.
Okay, super. Hi all, my name is Dudley. Yes. One moment, just need to sort something out. Sorry. Oh, sorry, 1 second, just some technical difficulties. Okay.
Okay.
Yeah. So my name is Dudley. I'm one of the developer relations team. I hope all of you enjoyed listening to my colleague Antonio about decentralized identifiers. Today I'm going to talk a bit more about the social KYC, what it's built from and with. So let's just move on. Okay, so these are the topics that I'll be touching on. First off, it will be an overview of KILT as a whole, who the team that built KILT and what it actually does. Then I'll move on to what is social KYC and how is it built. And number 3, about what building with social KYC and how does it affect your application. Number 4, how you can actually adopt social KYC into your apps. 1 second, it's just the ambulance going by. So. Okay, number 5, business use cases for social KYC, and finalizing just a little wrap up on the next steps of what's happening there. So, first off, what is KILT? Well, it's an identity solution, a decentralized identity solution, fundamentally solving decentralized identifiers using blockchain by issuing credentials and storing hashes of those credentials on the chain. KILT Protocol provides credentials and decentralized identifiers, giving users and builders the ability to issue and revoke credentials using DIDs. KILT creates a top-down trust mechanism with delegated trust to entities. At the moment, the active team is currently in the conceptual phase for a new trust mechanism. Hopefully, you'll hear a bit more about this in the coming months. So a little preview there. So how does KILT work? Well, actually, it starts with you by creating a DID. As my colleague Antonio spoke about in the previous presentation on decentralized identifiers, DIDs are verifiable and decentralized identifiers, allowing you to create self-sovereign and cryptographically secure identities for many different use cases. Each of these actors, attesters, users, and verifiers will hold a type of DID. You should check out his talk afterwards if you haven't already. So now that you have a DID, you can start thinking about KILT credentials. Well, attesters, they're the ones who issue these credentials, verify data for the credential and anchor the hash of this on the chain. So how do attesters agree upon credentials as standards? Actually, attesters may actually create and use standard credential types, or C types for short. For anyone can actually build these C types, which are based off JSON schema. So once you have a C type that has been created, certain properties are hashed, and that hash is then stored on the chain. And these attesters use these as reference points for credentials to be agreed upon. Maybe a group of entities or persons, such as a company, may come together and agree upon a specific C type that is used as a standard. Though through usage and wide adoption, creating that standard C type. So basically, each of these C types are each credential is based off the C type. So when a user wants to create one for a claim against themselves to have it tested, they find the C type that matches, and then they use it to create their claim. So there comes into another actor. They're called verifiers. So these verifiers verify the data. So they check what's on chain, and they see if the hash matches and the issuer of the credential, the attester, is trusted, or the entity behind the attester, such as a delegated entity. So once they've done this, they complete the verification and complete the workflow of KILT to a degree. So where did it all come from? It started a couple of years ago from Ingo, who founded BOTLabs GmbH. So 3 years on, a small team kicked off KILT Protocol, built on Substrate, and now released to the world. Now it's decentralized. It requires builders, maintainers, and businesses to take it to the next level. Hopefully that is some of you. So you have a little bit of background on KILT Protocol and how it works. Then what the heck is social KYC? It is an attested service for social networking accounts that is stored on the KILT blockchain. The service is centralized, but the beauty of it is that it never stores the data. It deletes all the records of the data afterwards, all safely in a trusted executed environment, or TTE for short, all done using the KILT protocol and the services to give the user a way to share their social identifiers from a trust source. So how does it work? You as a user want your Twitter, email, Discord account to be verified and attested by social KYC. So you come to the site, a series of crypto handshakes done in order to set up the secure session done by this Spiral wallet. The verification of the account they wish to be attested, such as your Twitter, etc., email, is then done via social KYC. If proven to be held by the DID user, then issues the credential. So this sends the credential to the social to the Spiral, and then the social KYC just forgets all of it and never knows that you were there. So it's great in that sense. Now the user can store and use their credentials elsewhere. So all the difficulty of the chain is distilled into a KILT SDK, written in TypeScript, and uses the DIDs for the identity solution and key management from the Spiral wallet. So, what is exciting about social KYC? Let me give you an example. The user comes to the website, Traditionally, a whole verification process is required by the application to check and create a user's login credential. The credential contains personal information. This needs to be stored in their database. With social KYC, things change a little. The application accepts different social KYC credentials, verifies the credential from a source of trust, e.g. social KYC via the blockchain. Once that data has been verified, the application knows it comes from a trusted entity, again, social KYC. Now the user registers to the application. So what does this mean? It gives the control and sovereignty back to the user and takes the issue of storing personal information in a database off the shoulder of the developers. Imagine the experience that the database is compromised from the application. They will receive no important information or data. The user has a chance to change the password on that specific application. Trust between the user and application is not entirely compromised, since the user controls all the important information on their side and not relies on the database itself. So, Web3 acts as a way for the developer to build utility from the credentials and does not hinder the application builders by having to create a whole workflow based around the registration or authentication process. So what does that all mean? What benefits do social KYC provide? Again, the control goes to the user, allowing them to manage, store, and present their credentials to whomever they choose. With their credentials owned by the user, portability skyrockets, potential utility, and with KILT selective disclosure means that users can protect private information from malicious users. So, how social KYC can change your application? Well, starting on the login, simplified authentication flow, regardless of what credentials you're accepting. Users might have credentials for application accepts, right? The user must have credentials that the application accepts. These credentials can be really specific or broad, depending on your use case. Well, instead of having one data point to authenticate, it now provides multiple data points to authenticate. Most of you who you are providing a service to more trust in that sense. So, what about the personal data being stored? The biggest point, in my opinion, as a developer, you don't need to store identifying information such as email, user, etc. A persistent UID can be actually be generated and owned by the user. This is then stored in the database and used with a password, access the login. Maybe you're thinking, how? There's many ways to do this. What about DID and password source to create this UUID that users control? Since DIDs give the user the control of their keys, they can rotate them out. They can change this from the user's control and just update the password when needed. So, a little on cryptographic challenges. A workflow to begin trust with a user on the site in the verification stages with the keys from the user's DID. So they gain that trust from the whole user's point of view. So some integration with Web3. It's decentralized by nature, doesn't rely on centralized services. You can either connect to a node or spin up your own node for communicating with the KILT chain. Soon, I think the most exciting part of the Polkadot and Kusama ecosystem is coming, and that's XCMP, so allowing for communication with additional chains, creating an ever-expanding set of use cases. One second. Sorry, 1 second. So, social KYC versus Web 2. What is this actually challenging or changing? Well, Web 2 and Web 3 can work together in order to come up with new services and new ways to. Sorry, 1 second. I need to solve the problem. I think my laptop is just lagging out a little bit.
It's okay. It's okay, Dudley. We can wait you a second.
Sorry, just bear with us for a second. Okay, sorry, bear with me. Yeah. Okay, so sorry about that. I'm having some problems here. Moving on a little bit. Just going off of just the basis of what you can do to adopt social KYC. How are you going to use it? Social KYC requires adopting from the KILT SDK, which provides a lot of features and helpful functions to ensure all workflows are available. Meaning that the application may require a node to connect directly to the chain, or rely on a public infrastructure provided by KILT and funded by the Treasury. Another tool the active developers are working on is a cookbook, or known as KILT Distillery, which is an on-ramp for people to build upon, creating use cases for identities and credentials using DIDs by providing tools, the recipes, and magics needed to start projects.
Excuse me, Dudley.
Maybe you want to projects to give them a fresh, new Web3 lease of life. On top of that, KILT Protocol uses the Web3 standards for DIDs. The Spiron gives accessibility to these DIDs and management of DIDs plus their keys, providing responsibility back to the user, controlling their identifiers. Therefore, the builder must accept the credentials and utilizing the DIDs in their application.
Excuse me, Dudley.
First off, we have DID universal resolvers. They essentially allow you to understand what's behind the DID, what methods there are. This is all based on the DID core and resolution specifications. DID service endpoints. These are a way for entities to interact with credentials from a public endpoint. It gives more flexibility to the builders and users. And actually, you can have a little bit of automation from this. So then we've got a bit about the KILT blockchain, to store the transactions from the attestments to the delegations, which is a way to extend trust from one entity to another. KILT SDK, it's built with TypeScript, provides helper and tooling for builders to integrate application or projects. BTE services provides the social KYC Spiron wallet that holds the credential and others. So, what about integrating your service with social KYC? An example of integration from Web 2 point of view, a user can use their Spiron to sign in for social KYC by accessing credentials from our TypeScript SDK. Since these are based off of JSON schema, it can be used in most applications quite easily with some tooling from Web 2. Making it cool to verify the credential, not much has really changed. Only you are giving a choice back to the user and getting control of their data. For example of integration from a Web3 point of view, most cases the Web3 will directly access the chain and create their own the application might even create their own attestments and seed types and using more KILT functionality. Not to say that the Web 2 applications can't do this too. The great thing about being part of the Polkadot and Kusama ecosystem will access the cross-chain messaging, what I mentioned previously, for greater use cases and more functionality. Web3 provides more utility and accessibility to these features. So, what's possible? Web3 removes the cap on utility, makes identity portable across brick and mortar. Web 2 and Web 3 worlds will, while giving the user ownership of their data. Imagine using your uni credential to level up your character or access the campus gym. There are loads of possibilities for you to integrate and utilize these credentials. I can't give you all the possible use cases, but the Web3 logins are a great starting point. More can be found about like a community Trello board. Every Friday, we currently have this Trello board for which a number of businesses and use cases that are available from our community. So you can look into and read about it. Myself and Paul, we are the developer relations team and hold a community talk on Fridays to go over this and talk about use cases. So you're more than welcome to come and join and take part as well. So, a little wrap up here. KILT Protocol has a treasury for those building services or tooling for the chain's betterment. How can you contribute and make a proposal? Well, the KILT treasury is a store of the on-chain funds that can be used for supporting and maintaining the KILT network. Maybe you receive a tip for work done, something that active developers are working on at the moment. What about changes need to be complicated? Not really. We as the community can take charge and work on it. We have some tooling, documentation, and concepts available for you as builders and entrepreneurs to begin with. Tim Berners-Lee did not envision the Facebooks of the world. Similarly, we cannot begin to imagine the full potential of decentralized identity and credentials. We do know that the future contains decentralization, and that you'll be the ones to build it. So, thank you for listening, and maybe take a step into the direction of KILT. Here's a number of our channels. Here you can check out where to be supported from our Clan KILT Discord, or speak to us on Twitter, or look at our documentation, or check it out our Telegram page. And finally, before going further into the presentation, a small note.
Give a sign if everything is okay. We were aware there were some issues, technical issues with Dudley's presentation, so I hope nothing was too bad to follow.
Okay, it's okay. It's wonderful. Thanks, Dudley, for the amazing presentation. Dudley introduced us in details about decentralized identifiers and social KYC. So in 2022, we are looking forward more about the developer expansion and the community expansion and the partnership expansion for the KILT protocol. So let me introduce explain something to our Chinese audience. So, wait a second. 那在刚才呢，就是 Dudley 为我们详细的介绍了这个 Social KYC 的一些，比如说他们是如何工作的，还有就是他们后续的一些孵化训练营之类的一些信息。那 Social KYC 呢，也就是让用户可以管理和存储，以及展示他们的个人身份，然后允许用户选择那些就是可以自主的选择什么私人数据可以在哪些服务的平台上可以被怎样的访问的这样一个流程哈。当然从名字我们也可以知道，就是 Social KYC 它其实主要的目的和目标就是专注于重新的控制社交媒体用户的这个数字身份。那目前 Social KYC 已经支持了 Twitter 和 email， 现在团队也在努力的就是添加更多的社交平台，比如说 Discord， 还有 Twitch， 还有 GitHub， 以及其他的一些去中心化的社交媒体网络，还有Metaverse 等等新兴的领域。那并且呢 Social KYC 也在为用户证明自己控制，就是当用户可以证明自己的这个是自己的账户以后呢，向用户颁发一些凭据来确认就是社交媒体或者电子邮件的所有权，通过依赖于他们有一种叫做声明者和证明者以及验证者的这3个要素来添加信任。就是当然就是后续也是非常期待我们去更多的了解 KILT Protocol 和 Social KYC。那当然呢我们今天也是同样的准备了问题，然后邀请嘉宾为我们作答。So okay, I'm going to move on to our panel. and more about our wonderful KILT protocol. And so, Antonio and Dudley, we do have more questions for you today. Welcome to join us for the Q&A.
Yes, please.
Okay, our first question is, what will come next for the blockchain identity? So, and this question is for both of you guys. So it will be really fun to get into that. So maybe we will start with Antonio. Antonio, would you please answer this for us firstly?
Sure. I mean, I think priority number one, because crypto and blockchain are becoming very mainstream. More and more people are starting to use crypto and decentralized solutions and blockchain-based solutions. I think the first important issue would be to raise awareness of the security implication of what this means, because if we don't have a centralized service that takes care of everything and stores recovery passwords and whatever users are the responsibility is shifted onto users, which has, of course, its pros and cons. So I think there is quite some work to do to raise awareness on what are the best practices, to avoid, scams or losing your private key or whatever. So you basically lose access to your account. But other than raising awareness, of course, metaverse and NFTs are definitely really exciting opportunities there, and they do need solutions that are they do need identity solutions, preferably decentralized, because it's a whole decentralized world, right? So you basically NFT buyers or NFT marketplace will have to implement some kind of identity solution to maybe even just KYC the users, or make sure that maybe get scams that cannot join the platform. And of course, also we could think of extending identities to also the machine world, or anything that is not just a human being, but also it can be like a IoT device or something like that. And because there are so many more IoT devices than humans, the possibilities are really, really limitless. And there's definitely room for growth there, and we hope to be at the forefront of this innovation here. Maybe Dudley has something more to add.
Yeah, actually. So maybe just go off one of your points is we want to provide identity solutions, but DIDs don't really limit which chain you have to be part of to have that identity associated with. So you could have the DID, but the account that you have on the KILT blockchain or Ethereum, all of these could be underneath one centralized DID. And, that's where the benefit really comes from, that we provide the accessibility or will provide the accessibility to users to have one DID for access through multiple chains and have all the credentials share this opportunity. So, it really extends to the interoperability of the whole KILT concept and the parity and Polkadot ecosystem, etc. We're trying to allow cross-chain messaging and everything. So there's going to be a lot of chains potentially with lots of different use cases, and having one or a decentralized identity solution and using DIDs can really be powerful for this, and doesn't handicap the utility of the identifier or DID in that sense.
Yes, definitely. Definitely. At present, we are still in a very early days fulfill the potential of the blockchain-based identity management. So actually we know that a recent report forecast that the blockchain identity management market will grow from the 107 million in 2018 to 11.46 billion by 2026, illustrating just how important this will become. And identity management is fascinating new use cases for blockchain and will be the subject of much further exploration, research, and investment in the years to come.
Yeah, I think it's nice that bigger companies are now somehow, aware of the technology, aware of the potential, and they are investing, even though it's kind of a small budget, but they're still starting to invest something in the area, and this can only be good for the overall ecosystem, right? Because if big players with very, very good intellectual pool, like good resources, join the field, they can just basically, improve the overall quality and extend the range of use cases where this technology can be used.
And it also lies in that sense that the more bigger companies join, the more people would start adopting, seeing that it's not just a barrier and only a select few are starting to use these DIDs or the Web3 solutions, that corporations themselves are seeing that it has its own benefits and advantages, and how they can drive that. They can also drive adoption. So more people coming into the space, seeing that there is additional choices. You don't have to just rely on the Web2 itself, but you have another alternative. Maybe in the future we'll see more, like instead of just having these two decentralized and centralized solutions. But it would be interesting to see, and gives real control back to the user. I can choose either I want to be decentralized or centralized now. So,
Yes, wonderful. May I explain something to our Chinese audience?
Sure.
OK，刚刚呢，我们2位嘉宾有提到，目前呢，就是我们区块链的去中心化的身份验证标识符，可以用于比如说我们的 NFT， 还有元宇宙，还有等等，像 Web3的一些 DApp， 以后都将是个非常好的发展的一个领域。那刚才就是我们的嘉宾也有提到，我们其实是还是处于一个区块链技术的早期阶段的哈。那类似于这样子的身份管理系统，还有很多可以开发的，并且被投资的一些机会。那现阶段它已经可以证明了它是能够复制现在基于现在的这个真实世界的身份系统，然后来构建一个更加高阶的一个互联网的版本，就是 Web3 啊。对，我刚才也有提到，就是我们最近看到的一份报告，就是预测区块链的身份认证的市场将会从2018年的1.07亿美元，然后增长到2026年的114.6亿美元。这也就说明身份认证管理是区块链领域这面一个非常让人充满期待的新沃土。那也将成为未来几年进一步探索和研究以及投资的一个主题。So let's move on to the next question. Number 2, the second question is KILT obtained an auction slot and launched mainnet as a parachain on the Kusama on September 8, 2021. Which roles does KILT play in the Polkadot and Kusama ecosystem, and what impact does it have? So, Dudley, would you please answer this for us firstly?
Yes. So really, what we're looking at or seeing is the potential of having identification solutions on Polkadot or Kusama as a whole ecosystem. So that provides a lot of usability or visibility for collators or validators from the network to identify themselves, providing a little bit more trust to know who they are. And in the future, we're looking at potentially giving them some much more readable identities on the chain itself. So that's one part of it. But then the other falls down into the credentialing, talking about social KYC, we can start providing credentials to different use cases throughout there. So anyone who's looking to have some specific claim about themselves are able to do this from the KILT's perspective and really provide a lot more transparency, in my opinion.
Okay. Okay.
Just wanted to add that we recently also ensured a second slot, which will then run until March. So we're just making sure that we have all the time we need to build what we are building and provide all that we're building to the community for them to then build upon us, which we build upon the Kusama and the Polkadot ecosystem, right? So yeah, I think it will be very important, the interoperability, especially that is somehow the recurring theme in the Polkadot and the Kusama ecosystem, by having this relay chain, parachain chain system and bridges between parachains. The ultimate goal would be for multiple application-specific parachains to communicate with each other. Each of them does one thing very well, and we hope to be the identity parachain that other parachains and relay chain, or also other blockchains like Ethereum or other solutions out there via bridges, that we can then be the identity solution inside this space.
Yeah, stuff like that.
Okay, that's wonderful. So the KILT blockchain is live and running as a Kusama parachain in the Polkadot ecosystem, and Polkadot addressed a lot of problems such as security and stable transaction phase. That's also a Harvard blockchain used to the date. So we know that the community around the KILT is constantly growing and forming support ecosystem for those interested in building on KILT protocol. Anyone who wants to run a successful business and tap into the KILT blockchain can join the conversation and collaborate on Discord, right? It already have more than 2,000 members, right?
Yes, please do. Please reach out to us if you have even just questions which you think might be stupid, but we definitely think they're not. They might be also helpful for other members of the community. So yeah, please reach out to us. Probably mainly the main communication channel will be Discord, our clan KILT on Discord. And yeah, please follow also our updates on Twitter and the other social media out there.
Yeah.
Wait. Please go on.
You want to say something?
Yeah, most Fridays, me and my colleague work together on speaking about use cases and betterment of the KILT chain in itself. So you can always drop by, join in these discussions. They're completely open for people. And we look at just how KILT can build use cases and what we can do to really drive this adoption and make it a bit more easier to onboard people into not just KILT, but onto the whole Web3 community. So yeah.
This happens on Friday afternoons, right?
Yes.
So probably for the Asian community it will be Friday evening. So if you are really dedicated and passionate, just spend your Friday joining our our community sessions, and yeah, you most likely won't be disappointed.
Yeah.
Yes. Yeah, we do hope your project will have more development and collaborate in the future in different fields.
Yes.
Okay, let's stay tuned and catch up with the development of KILT protocol. So thanks again, Antonio and Dudley, for today's amazing sharing about what you have done. And take care. See you next time.
Thank you. Thanks again for the invitation. See you next time. Bye bye.
Bye. Bye. 好的，再次感谢我们的嘉宾 Antonio and Dudley 今天的精彩分享，让我们期待2022年 KILT Protocol 在更多领域的进一步发展和合作。好的，非常感谢我们原力开放日的嘉宾呢，和我们守在直播间的小伙伴们。那原力区 Web3 先行者系列活动后续将会继续为大家带来有趣的话题及生态资深大咖的分享，欢迎关注我们的公众号，加入我们的 Telegram、Discord， 在社群内和我们互动交流，精彩活动第一时间知道啊！谢谢大家，我们下周二再见。Thanks for everyone. We do hope you have a great day here with us. So see you next time. Bye bye.